Okay. Now, I have a very wordy title, but hopefully as compensation, I have lots of pretty pictures. What I'm going to be trying to do today is I'm going to give you some introduction to my materials, because I imagine I'm the only person here who does research in signalography. And I thought it'd be useful to have some context. And then I'm going to try to shade from there into thinking about machine learning. Okay, so the project that I curate is I call it the Digital Signalography Resource. And I've been working on it for a little over 10 years, I suppose, with numerous collaborators, including students. And the aim of the project is to bring together publicly accessible information about medieval seals and seals more broadly. At the moment, I think if you go onto it, you can get to something like 50 or 60,000 seals. So quite a substantial data set. If you go into the data set, you'll find that there are, broadly speaking, two main kinds of seals that you can look at. There are seal impressions, and these are the kind of the balls of wax that are attached to documents. But you'll also find seal matrices, and these are the stamps that are used to make the seal impressions. So in a sense, these are the positives and the negatives, if you want to think of it in those terms. And if you're curious, this is a bunny rabbit with a horn riding on a dog. That will come in later, but I'm also tell you that right here. Okay, so pulling these two forms of seals together into one project is in some ways quite straightforward, because they are the positive and the negative. The matrix and the impression both convey information about the visual and textual content of the seal. The impressions tend to be held by archives, so we're working with archival seal catalogs generally when we're taking information there. And the seal matrices are objects, at least they're treated as objects, and they're artifacts, and they're often in museum collections. So they're often recorded by archaeologists. So the complication is not in the content so much as in the information that surrounds these objects, the information that sets them in a historical context. So, for example, how do we date the seal? If you're dealing with a seal impression that is attached to a document, in some ways it's pretty straightforward. You read the document, and it'll often tell you exactly the day that the document was composed, and that allows you to say something like September 21st, 1372, this seal was in circulation. What do you do with this? This was, this kind of seal was probably dug up by somebody in their back garden and then brought to an archaeologist who wrote a report, and maybe it entered a museum collection. But there is no contextualizing information there to tell you precisely when this thing was in circulation. So the way in which you date this is by going and looking for seals in the archives that are attached to documents that have similar features to the seal matrix in question. And then you make the argument, seals with these features were in circulation in this period of time, therefore this seal matrix is likely of the same period. Okay, so I pull all this material into my database, but effectively I've got two different flavors of dates when I deal with the seal. From the seal impressions, I have very precise dates, and from the seal matrices, I often have these broader span dates, which are subject to argument and revision. And my thought a couple of years ago was that because I have this very large data set of seal impressions, that I could help the archaeologists do this work. That maybe I could even automate it to some extent. So you could come to DigiSig and say, I have a seal which looks like this. Show me other seals which look like this, and give me some sort of report on when these things were in circulation. That sounded to me like a good thing to do. So I tried. And it proved to be far more complicated to achieve than I first imagined. And after a couple of years of work, I ended up using machine learning. What I did was I devised a training data set, which I extracted from DigiSig, which had information about the size, the shape, and a classification description of the image content. and I passed it to a decision tree algorithm, which then constructed this chart, which allows you to follow through, and it groups the seals together into clusters where the seals all have both similar features and similar dates. So you can now go on my website, and there's a little menu on the side. You can fill in information about your seal, and you'll get back this report with a little graph which shows you the distribution temporally of things with those features. And you'll also have on the side a little report on how it actually managed to make that decision. So a lot of information there which tells you how the computer went about solving this particular problem. Is it any good? Well, what you can do is you can compare the way the machine does it to the way a human being does it. That's one obvious way of testing this. And for example, if you take the machine and you apply it to Linenthal and Knowles, for example, catalog of seal matrices from the Scheuing collection, and you pick the seals with rabbits running on dogs, blowing horns, and you ask the machine what dates it thinks it is. The machine's on a kind of the black, blue color there, and the human being is the red. And you can see that typically the machine is much more cautious than the human being, but it's in the same ballpark. So as in terms of an automatic tool, it's really not all that bad. And if it is trustworthy, then you can start to do all sorts of really cool things, like take the entire set of seals and you can start to map out how they change over time and what kind of groupings they have. Do things change fast at some points and slowly at other points, which is really kind of fun. But before you get too excited, I think you should also use the machine learning results as a point of reflection. And for me, as someone who's trained for many years to do this by hand, I feel really conflicted with the fact the machine can do this as well as it can. Partly because I don't want to be, I mean, I guess I'm kind of putting myself out of a job, but not really. But what kind of bothers me about this is that the machine is not doing this the same way a human being would. If you look at that decision tree, the black nodes are all decisions based on the size of the seal. Now, as a human being, I tend to think more in terms of the images and their style and the style of the lettering, the things that are visual, unique, and distinctive, the things that are specific to a certain moment in time. I seize on those things, and that helps me narrow down the options. The computer works kind of the inverse. It works from the things that are common to all the seals, and then it parcels them out. It also tends to work on the things which are easily quantifiable, things like size, which, I mean, I can't look at a catalog and say 12 millimeters versus 14 millimeters. That's important. I mean, maybe intellectually I know that, but reading thousands of these things, that information does not stick in my mind. But the computer makes it absolutely central. So the computer is doing this differently than how I would do it as a human being. Now, that is kind of exciting because it means that the computer is opening up a different way of addressing and solving this problem, a way which I would never have arrived at independently as a human being. Now, it may not do this as well as I do it, but it is saying to me that perhaps there could be a better way of doing it that takes advantage of both the strengths of the computer and the strengths of the human being. Couple other subsidiary points to that. The fact that this is a graph means that I can share this with someone else and show them exactly how it's done. When I do this by hand, I can't really explain to someone exactly how it is I made that decision. That's just not how human beings work. I do it too intuitively to really break it down. And I think that also is a kind of a fundamental challenge. It's also saying to us as human beings, we probably need to do a better job, if we're going to do it by hand, of documenting exactly how we do it, so that at least we can compare it to the way in which the human being does it and have more of a dialogue. So, as a final conclusion, even if you don't think that machine learning is going to help you solve your cultural heritage problem, it can be a very useful experiment to run because it may offer you insights into alternative ways of solving your problem. which might in fact lead back into you improving the way in which you address it. Thank you.